Thank you so much. So can someone quickly help me with what is it called? The screenshot. Does anybody has a screenshot? The image of that architecture I drew. I don't seem to find it. I was hoping I would see it here where I used to, but I can't seem to find the architectural diagram I used. Does any of you still have that?
I think I have. Let me check this.
All right, please kindly share. I'll be grateful. It's going to help me to elucidate a lot of things and make it easier. All right, so while that is coming, today, let me just write down the things I will try to explain in today's session. And one of the things I will try to explain is how developers work. Okay. 2, we'll also try to explain how code is built. It's almost the same thing, right? So I think it's fair if I put it like this. It's almost the same thing. So I can also show us programming languages, right? This once the screenshot is available, kindly let me know. Then we'll talk about okay, we'll just talk about 2 sides of development. Then we will talk about do I talk about that? Okay. Okay, it's fine. Let me just put it here. Send to the okay, thank you so much. I think somebody must have sent something. I will check it now, sir. We'll talk about installation. We'll talk about installation. We'll talk about what is okay. Talk about build tools now. Okay, then we will proceed to talk about okay. I think that should be enough. I should do a demo, and if need be, I could maybe talk about let's see. I just hope there'll be enough time. Packaging, which is the same thing as artifacts. Okay, and I don't think so. We need bundling and unified bundling. Okay, bundling. Okay, then 9 could be maybe container or section. No, I don't think there's anything for. Okay, this is good. This is good. I hope it's not overwhelming anybody yet. So let's save this. This is going to be okay. Let's bootcamp. Okay, just for now. Okay, good. So let's go back to this. Thank you. And okay. Okay, something similar. Oh, or is there another one? Okay, let's use this one. Thank you. Thank you. Thank you so much, Mr. Benga. Thank you so much. Let's use this one. Yeah, thank you. This is clearer. Okay. So for some weird reason, it's blurred. Is it just me, or is this happening for everybody? Seems to be blurred. Okay. The most important thing is we all can still see it. Okay. So, or we have it on our PC. Now, sadly for me, since I did not save it when I finished doing it, it's going to take me time to start sketching this again. So that's why I just felt, okay, let's use the one we already did. So remember I told you all, friends, to have a mental picture of this entire end-to-end pipeline, right? Because it's very important that you have a farsight, the big picture of whatever you're building as a DevOps engineer, all right? So, and you are conversant with what is happening at every stage of every pipeline and what you're doing. Okay. Now, we understood how code can be built here, right? Even though we're going to talk about it too. Now, we said developers are going to write code and then they're going to store it somewhere on the central repository. Okay. Now, they are also with the help of something we call one of the principles of DevOps, which is called continuous integration. We're going to set up a server that will do that principle. And because of that, we're going to perform something we call build operation on that code that is stored on the CI server. Okay? We're going to perform a build operation. And at the end of it, we are going to package something we call artifacts. And those artifacts can be stored, okay, in repository managers like Nexus or JFrog Artifactory. You understand? So this is the little things we did or discussed in the previous class. Most of these things I said will be making sense over and over again, okay, because I'll always refer back to this. Again, I said developers code is stored on GitHub, because we want to be able to monitor the code that is stored here as developer pushes, and with the help of a tool, we will which could be
Hello, we
Jenkins.
can't see
You're
your screen.
breaking so
Okay.
bad. You're breaking so
And you
bad.
are
Oh,
really
wow.
breaking, yeah.
Yeah.
Is this the same for everybody? Friends,
No, grammar, yeah. Okay.
ooh, I'm so sorry. I'm so sorry, guys. Hold on. So, okay. I just turned off all the devices and turned off the other laptop and the TV set. It's all here.
Nothing changed. Achiever. Still the same thing.
So can you also see this image? Let me know if you can see the image. Let me open it again. Can we see the image?
Yeah. Yes, we can see.
Okay, good. Okay, good. Thank you, friends. So from what I was saying,
Sorry, I can't see any image. Am I doing?
this
Yeah, image of the architecture that you're
the
showing me.
architecture we used in during the first week,
Yeah,
the
I
one
can't
that's
see it.
currently on the channel, you can see it.
Are you sharing it on your screen? If you are sharing it on your
Yes,
screen, I can't see
I am.
it.
Okay, is he the only one? Two persons has confirmed that they can see it. Wow.
So actually, I think the only thing that's showing right now is your wallpaper.
Wallpaper.
Yeah, you need to share your system.
Okay, well, which means for some reason the way this guy works is different. Maybe because I'm sharing every single thing and
Yeah. So you need to maximize. So you need to click on the diagram you want to share because you're sharing your whole screen. So I think you didn't open what you're sharing.
so when developers write code, okay, they push their code to a source code manager, okay, SCM, that's what it's called, or VCS, version control software or system. That's what they call this, okay? It's GitHub, GitLab, and the rest, Bitbucket, okay? So that's what it's called. So they store their code here, and then that code here, with the process, the way DevOps engineers are supposed to practice the principles of continuous integration, right? To monitor the codes that the developers are pushing and then working on it, they set up a server, okay, for that CI purpose, that continuous integration. That's what I mean by CI, okay? An example of CI tools are Jenkins, GitHub Actions, and GitLab, all right? Now, the code here is usually being built, okay? We build this code, okay? I'm going to explain what I mean by build, okay? We build this code, and the building we do, right, is dependent on the type of language, okay? That is why if you look up here, you see MS Build, you see NPM, and you see Gradle, Maven, and you see Ant. Gradle, Maven, Ant. These are what we call, you can call them build tools or package managers, okay? Now, so, and it's dependent on the programming language. I'll still explain all this. So, after the code is being built, a file or multiple files are being generated. Usually just one file is generated, which is called an artifact, okay? This artifact will be stored somewhere, okay? Now, it's deployed to a server, or you just save it for saving purposes, just for the purpose of documentation or references. So two locations or servers where we usually store this kind of things is referred to as Nexus and JFrog Artifactory. There are so many others, popular ones, okay? This is the phase we are going to dwell upon in today's session. You understand, from this point to this point. And that is why if you watch what I said, we have code, the code will be written, the build will be done, the test will be done, and the deploy will be done. How does developers work? How is code built? The same thing, but contextually could mean two different things. I'll give you an example. I don't know, I think I've said it before. I once got a job. After an interview, I wowed them during the interview, and then I got a job when I started, when I was very, very young. By that I meant early days in my DevOps career, right? And I went into my first day at work and trust the Nigerian ecosystem. You are supposed to start working from the first day. They are not going to tell you, okay, this is all the company policy, go read it up, and you're going to start work next week or or get familiar. No, you're going to start working the firm the first day. So they asked me to provide my email address. And when they provided me an email, when I gave them my email address, they used it before this is before they had created an official email address. So some companies will create an official email address for you. Some will just use your personal, okay? But best practice is just to set up an official email address for you. So the most important thing is that I gave them my email address. And with my email address, they were able to add me to their official GitHub account as a member of their team. Does that make sense? Please, I want you all to have this mental memory. Just try to remember it, okay? We will still touch some of these things practically when we get to GitHub, okay? So they collected my email and added me as a member into the GitHub team accounts, right? Now, that gave me a lot of ability to read and write code, okay? It means I have administrative access over the repositories or folders in their GitHub account where developers push their code. Does that make sense? So, as a DevOps engineer, my first task was I should go through the whole repositories there. I'm going to see a specific repository. Another word for repository is called folder, okay? I should go through that repository. I should find something called Backend API. Backend API. They asked me to deploy the application and share the endpoints. In other words, I should share the results, give them the status code, okay? If it's working very fine. As simple as that task sounded, it was sounding like a huge bomb for me, right? And I claimed I knew a lot of things. Now, they didn't ask me how I'm going to navigate all through these things and get to this place and give them an IP. They were not interested. They just gave me the simple task and I'm supposed to run with it. That's what they want. Anything you want to use, any tool, any magic you want to use, just deploy it and give me an IP to test it. Do you understand? Okay, so what did I do? Now, what I did is I decided to go online to go and make some research. First of all, I asked them the question, okay, what kind of project are they working on? And they told me. Of course, I could see it on their GitHub because on GitHub, there's something they call the README documents. Okay, there's a document I could read. So I read the document and I was able to tell the type of application they were building. All right, because I haven't built it before, it was overwhelming. I went online and did some research and I was able to learn how to build a sample application, even though of not that same size, but a simple application that mirrors exactly what the company was building. I tested it on my computer system. I tested it on my local computer system. It was working fine. And that was when I confirmed it was working fine, then I decided to now utilize AWS EC2 and did one or two things, connected with some pipelines and did everything. And I was able to get the application up and running. The CI was up and I gave them an IP. They were able to confirm. It took me a lot. I think it took me 2 days or so, right? But the fact is, I still got the job done. They were excited, right? At least I have I doused that fear that I could handle the job, because the feedback expecting me to give them an answer and I haven't come up with something made them feel like, okay, this guy doesn't know what he's doing, right? So please, it's very, very important. So one of the things developers will do is this. Developers usually write codes. You understand? Now, they will consider a whole lot of things. Okay? I want you to know that some of the things that you will likely do in your deployment, the developers do some of them, but on their local machine. Does that make sense? The developers do it on their local machine. All right? Now, when they finish writing the code, right, the developers are going to test it. They will test it on their local machine. They will do the build and test and confirm everything is working very, very fine. Okay? When they are done, they now give it to you to deploy it to production servers. Okay? Take note, there is a difference between what local server and I wish I can put this, okay? It's not, local server is not equal to production server. Okay? Very, very important. Now, so the next thing that usually happens is you need to know the type of programming languages, right? Of course, the developer will write in different kinds of programming languages. When I say different kinds of programming languages, the code they are writing, right? This code can either be written in HTML, it could be written in CSS, it could be written in JavaScript. Okay? Let me just copy all. Let me copy this. It could be written in JavaScript. It could be written in React. These are libraries actually. So let me just put it. It could be written in Python. It could be written in Java. It could be written in .NET, C#.NET. Let's put it this way. It could be written in Ruby. It could be written in PHP. It could be written in, okay, I've written JavaScript, okay, which is usually Node.js, but let's just leave it this way. Okay, friends, this among many others are languages that developers usually write their code. This is very, very important. I agree that you all are not the developers, right? You're not the one writing the code. Okay, that is true. But you should have an understanding, okay, when they tell you, okay, because during the interview, one of the questions they will even ask you is, okay, so do you have experience in this programming language? That's the reason why they ask you, you should have experience in so programming language during the interviews or during the job description. If you see any line that seems have experience in so programming language, they might not necessarily be saying that you are going to write the code. You should have experience in deploying applications written in that language. You should have experience reading that kind of code. I hope this is making sense to everybody, right? So either it is in JavaScript, Node.js, Python, Java, C#.NET, Ruby, or Python, or even C or C++, right? You may not necessarily know all of them, but of course, as DevOps engineers, your power lies in the use of Google, how to search and find your way out, ask questions in community, and get the problem solved. You understand? Not all developers knows everything. In fact, not everyone knows everything. I've seen people who has years of experience and it takes them weeks to solve a particular problem. Okay, so I want you to know that there are different kinds of programming language. This is very, very important. Very, very important. Very important. Okay, now that we've been able to establish that the codes that the developer are writing can be in different programming languages. I want you to understand that the developers, the way they build it, right? The way they are going to build their code is based on two things. Sometimes their application is built as front-end application. Sometimes it's built as back-end application. Of course, there can be more, but let's just limit it to these two, okay? Now, what do I mean? I'm trying to make this very simple for anybody that doesn't know anything like this. That's why I'm explaining it. Now, when we say front-end application, so it could be, why I didn't put anything in front here is because it could be web, front-end web application, or it could be mobile application. Does that make sense? So I don't want to confuse. Just know front end and then back end. Okay. So now the developers, when they build their application, okay, using this, okay, so it could be front end, it could be back end. There are languages that is usually strong. Like for back end applications, we have these applications. Example, e.g. are these applications here. They're used for writing back-end applications mostly. And then these three, e.g., are usually used. Of course, I think they can be more though. Yeah. I think I've seen someone using Ruby. I can't really remember. But most especially HTML, CSS, and JavaScript is usually the language of the browser. You understand? But I'll just keep it very simple. Okay. Now, you may be wondering, why am I explaining this? And what do I really mean? When you are asked to deploy the application as a DevOps engineer, you need to know, is this a front-end application or it's a back-end application? Because a front-end application has to do with the UI. Do you understand? The UI. The UI, what you see. For instance, if I come to this website, okay, let's say CNN, okay, like this beautiful website you see here, okay, what we have here, okay, this is the start page of, it's, of course, it's maybe an advert, right? But okay, let me go to CNN. Say CNN. Okay, let's go to CNN. So this is the front page, right? This is what you are seeing. You can click the button. You can interact with this button. Okay, this is the front side of it, right? Now, did you see sign in button here? Can you see a sign in button here? If I click on this sign in button, it's going to require me to log in, as you can see here. Okay, it's going to pop up and ask me to put my email address, right? So if I put this email address and I put a password and sign in, it's going to be checking with the back end to confirm, and the database to confirm if there is such a user with that profile before it lets me in. Is that true? So that back end is what does the processing and the logic. You understand? But the UI that we see, feel, and interact is what we call the front end. Does this make sense to everybody? The UI is what we call the front end. Okay, so but usually maybe I don't, it's not always true, but database, logic, and let's say, yeah, different kinds of things, maybe cache and the rest of them are and APIs, they're usually for the back end applications. You understand? Back end, the user cannot see the database. The user cannot see where the logic is done. The user cannot see the cache server, okay? Or even what we call queue server, message queues and the rest, or even the APIs. The user cannot see any of these things because those are the back-end applications, okay? So, but the one the user sees and interacts with is called the front-end application. Should you know these things other than this? No, as a DevOps engineer. just know that there's something we call front-end application. There's also something we call back-end application. I hope this makes sense. If you are in the development space, you may have heard about some libraries that is built off JavaScript. You may have heard about things like TypeScript, script. You may have heard about things like React, Vue, Angular. Okay, you may have heard about things like this. So these are all extensions or libraries that, when I say libraries, they're like how do I put it? An extension of this JavaScript, okay, which is usually used for building front-end applications. Okay, so as a DevOps engineer, you should know that there's such a thing called front end. So when the developers gives you the code to build, you should have a mindset. So if they tell you, okay, the stack we use, they usually use the word stack. Okay, the stack we are using is React and Vue, or they could tell you React and Django, or they'll just tell you something. So I want you to have a mindset, if you understand this, so that in the future, right, when you've learned all the things we planned for you all, right, based on the outline, right? Let's say you learned everything that we have here. Okay, not this. Okay, if you learn everything that we have here for you all, right, you should be able to know where you still need to go and learn some extra things. That was why I told you in the beginning of the sessions to get a notepad or a document, a book, so you could be writing some thoughts or extra things you need to learn or do research upon. Okay, it's very, very important. Okay, because you could be working for a Fortune 500 company, a fintech company, a medical company, a law enforcement company, or a health company, right? And each of these companies, their developers will be using different kinds of programming languages or stacks to build their application. You may hear things like men stack, okay? You may hear things like min stack. You may hear things like Maven. Yeah, I think this is it. Don't worry about this. We'll talk about it later. Okay, this is MongoDB. This is Express. This is React. This is Node. This is MongoDB. This is Express. This is Angular.js, and this is Node, if I'm correct. Yeah. So, and this is Vue, the same thing. So, but all these things I just showed you here, they are what and how front-end developers build applications. Your job is just to deploy it. Deploy it. That's just what your job is. Remember, what we are learning is how to build and deploy applications. Your job is not to build. Okay? So, because different application has different ways of building and deploying them. Okay? So, that's what we are trying to say. I hope this makes sense. Please, if you've understood so far what I've said so far, can you just type yes on the comment section if you understood so far? If it's confusing, please let me know. Does this make sense so far? Okay. All right. Thank you. All right. Thank you so much, friends. Thank you. So let's continue. Remember, if you have a question, don't hesitate to drop it real time, or you can write it down somewhere so you can ask me later. Okay. So I can be able to address it, because if you forget, you might not do justice to yourself. All right. Now, I could dwell on some of these things, but I'm trying my best not to put so many information so I don't make it so overwhelming or boring. You get? So that's the reason why. So now we've understand that there can be two sides of development. Now, I want you to understand something. That these codes or these languages you see here, some of them, right, are compiled. Some of the programming languages are compiled. compiled, others are transpiled. Do I use the word transpiled now, or yeah, I can say it's more or less I say translated or transpiled. Let me say transpiled. Okay. I'll explain what I mean by that. Another word of saying translated, especially if it's an interpreted language, but I don't want to confuse you because this is not programming. So what do I mean? Now, the browser is what usually displays the front end application. We interact with the front end application through the browser, just like I showed you CNN. Is that true? When I showed us CNN, we were able to see it, okay? And then we can be able to interact with it, right? Good. So, sorry. Now, the browser by default does not respond properly to compiled languages, okay? So usually, there's what we call transpiled, okay? Now, if you look at this web page you see here, if you check the lines of code they use in writing some of these websites, it's so much and so large. The files are so large, both the images, both the visuals. You understand? They are so much. The files are usually so large. Okay. So one of the things, if you right click here, right click anywhere and say view page source, you're going to see something. It's going to show you a minified version of the code. Minified. That's the word, minified. Okay, the files has been compressed. A lot of times the spaces has been removed in some of them. Okay, especially if you start looking at it from this side, and if you look at, can you see how lengthy this thing is? So there's a way this one was, the section I'm even referring to. You see something like this. Everything is joined. Can you see all these things here? So I'm sure this is the back end section of it. Now this can be confusing to some of you, and you'll be wondering, what is all these things? It's the code, the normal code, you know. The only difference is that they had to so most of this code, right, has to be they compress the file, okay, or what we call, you compress it and bundle it. Sometimes for front end application, we use something we call Webpack or Grunt. I don't want to so this is for JavaScript application, right? There's something they call Webpack and there's something they call Grunt. Now, it is the developers that do this. I'm only saying this for your understanding, okay? For your understanding. Don't forget it, okay? So whenever you see those versions of code, because sometimes you may look past, do some things to reduce it, okay? But for back-end applications, mostly we usually compile those codes, compile it, okay? When we compile it, we can now test it and now decide to package it. Okay? Take note of what I said. We'll compile the whole codes together, bring all the whole sections of the codes together. Okay? If you have a section that talks about the menu, this is the menu. We have a section that talks about the footer. This is the footer section. So different components of this web page, okay? All those components can be compiled together, okay? You test it and then you package it. It's in the build process. It will make more sense as we continue, okay? So I just want you to know that such a thing as compiled and transpiled, that's the only thing you should know at this point. Now, whenever once the applications are done with this operation, right? We usually have two formats for applications: installation, two installation types. Applications is usually seen as one, executable, the formats are .exe or MSI. Have you ever seen some applications, whenever, especially if you're a Windows user, you notice that you see it usually ends with .exe, good, or MSI. Now, if it's for other applications, other type of operating system, you'll be seeing it based off their package name, DPKG or DEB for Debian packages. Okay. Now, the second type of installation we usually have is what we call binaries. Okay, binaries, and it's usually in DLL format. Okay, but this is for Windows. But just know that this is called binaries. Okay, two ways. It's either the application is packaged as executable, or it is packaged as what? Binaries. Okay, don't forget this. It's very, very important. Okay, now if you see an application that is in either of this format, okay, this format, I want you to understand that applications that are executable, right? Applications that are executable, they are usually created in a way such that they have all operating system services or service. What does this mean? It means that whenever you install the applications, right, they usually are located in a single location. Okay, they're usually located in a single location, and okay, and they are added to the system part. Now, let me explain something to you. I'm going to use this Windows computer as an example. Let me so this is a Windows computer. Friends, anytime I install an application, if you click on the C drive and double click on this, did you notice that there's usually something called program files? If you open this, different applications, for instance, maybe I installed Git. Did you notice that when you open Git, you see all the Git application files located here? Do you understand? So, like this is where the applications are usually stored. Sometimes it's stored inside this bin directory, where you see the application itself. You understand? So, but the most important thing is that most of those applications are stored all in one location. And then there's something we call system path. It will make sense later on when we start configuring some things. Have you ever tried to, maybe you open your terminal, let me type git, for instance, bash. So, did you notice that regardless of the location where you are, did you notice that, okay, like when we were talking about vagrant, did you notice that if I type the vagrant command, it's going to respond? If I say vagrant -- version, it's going to work. Is that true? Now, if I do the same thing, let's say I cd into desktop and I run the same command, it's going to work. Why? Regardless of the location, anytime I call this application, it's going to work because the application was added to the system part, right? Such that when we say system part, what are we referring to? We are referring to what we call environment variable. Maybe some of you have seen it, some of you have not seen it before. Okay, but if you watch here, let me type environment. If you're a Windows user, this is not don't worry, for that of what is it called, for Mac OS, we're going to get those who use Mac OS. When we start doing things around Linux, it's the same thing, so I'm going to explain it. Okay. All right. So if you click on edit the system environment variable, you're going to see this kind of pop-up. Does that make sense? Did you notice that when we click on environment variables, you're going to see this, and then you see system variables. This is user-based variables. Now, there's something we call path. So when you click on path and you click on edit, you can see some applications we have here, like Vagrant. So we added this path, like the Vagrant application. Okay, like this Git application now. Did you notice it told me go to C drive, program files, Git, and CMD. So if you open this CMD, you're going to see the Git application. So this Git application here, this particular one here, inside this folder, it's telling you when you go there. So that is why anytime you type Git command from any location, it's going to respond, because by default, the system will go and look for it in the environment variable and say, okay, go to this location and invoke the command. Now, but if you work with something we call binaries, okay, or source code, right? Now, this will happen during installation sometimes in the future, and you will notice that they'll tell you you have to copy this, add it to the path, do this, add it to this. It can be very, very confusing, but sometimes some applications are designed that way. You can't help it. You have to be the one to manually. Okay, let me ask you all a question. Did you notice that sometimes if you've done it before, whenever you install something on, let's say, on a Linux computer, sudo apt install something. For those of you that have gotten to that point in Linux, sudo apt install something. Do you notice that sometimes behind the scene, right, it goes to pack all the whole. What does Linux do? Linux scatters it. Some files goes to etc configuration, some files go to /user/bin, some files goes to /var/log. It goes to different locations. It's because most of those applications are packaged as binaries. Okay? So sometimes you have to be the one to manually go and add it to the system part. Okay? And by system part, it's usually in the environment variable. We are going to talk about all those things, which you can use set or export to do. Okay, I don't want to confuse you again, like I used to say. So this is where we're going to stop. I just want you to know that there are two types of installation. Okay, so this is the same thing as this. The only difference is that this is not usually found in the same location and is usually not added to the system part. Okay, now let's talk about build tools. So when we say build tools, what are we talking about now? This is where the interesting thing comes. Friends, I want you to know that if your developers are building their Java applications, you understand, one of the tools you can use to automate the way the developers build their code is called Maven. Some of you have heard about it, but I'll explain it. Another one is called Ant. Another one is called Gradle. These are the popular build tools for Java-based applications. If the code that the developers are building are .NET applications, when we say .NET application, I'm talking about C#, right? They usually use MS Build, or you can use
again.
MS Build. I mean, this, okay, .NET application, so it can be C#. C# is the language, but of course, in most contexts, it can be .NET application, it can be Razor, is it Razor? It can be Blazor. They're different. It can be even be what we call this Xamarin also. There are different architectures or ways you build C# applications. Okay, but most of the times the DevOps engineers usually use MS Build. Okay, or they just build everything from their Visual Studio. Okay, Visual Studio, not VS Code. Okay, Visual Studio. Okay, now if it is a Python application, they usually use, this is a popular one, they use pip. Okay, pip. Now if it's a JavaScript application, which in most cases it could be main, when we say main, mav, or min. So, or Node.js is just the same thing, but don't worry, I'll still explain some of these things later. JavaScript applications, we usually use NPM or yarn. Okay. If it is PHP, we usually use Composer. Hopefully I'm correct. Do we have developers on this call? Please correct me if I'm getting some of these things wrong or I'm mixing them up. Do we have developers on this call? Please let me know. So far, is it overwhelming? Are we learning something? Let me know. Can we unmute? Somebody unmute and say something, please.
Go on, sir.
Okay, that's fine, Tejarin. But please, if you can type, that'll be helpful. Okay. I want to know, what are your thoughts? What do you think? Does anybody have a contribution? Okay, a Visual Studio Code is more like an interactive development environment. It's okay. It's a heavyweight, unlike VS Code. There is a lightweight version that you use in building codes. But the Visual Studio Code has a whole lot of. It's used for building and packaging a whole lot of application. Yes, it's made by Microsoft. Let me show you quickly, sir. Let me come here, sir. So, okay, so Visual Studio. So if you click it, it's a very, very rich application. It's used for, you can use it to build a whole lot of application. You can even use it to build Python application. You can use it for a lot of things. Build web application, cloud applications, desktop application. You understand? Mobile apps, services, games. It's different kinds of things. Unlike Visual Studio Code, that is just a mere text editor. But this one is different. It's a big boy that has a lot of capacity and capabilities. All right. Okay, friends, let's go back to our notes. So I was saying, if we have any contribution as well, because I'm also open to learning because I learn every day, right? So if you think there's something I am saying that you guys must have, I'm saying something that I mixed up, or you have a better informed perspective, please let me know. Okay. All right. So let's continue. So having said that, so let's come here again. The next one we have is do I give more? I think so far it's okay. So far it's okay. If I mention anyone else, which other popular one? Okay, let's just leave it at this. Let's just leave it at this. So the most important thing is most applications will usually be this 5. Okay, there could be more. Okay, let me see. Yeah, I think I can remember either C or C++ application. C++ application. They usually use something we call the make file. Make. That's what it's called. You can just check it out. Okay, so now, so that this thing can be visually organized, sir. Okay, good. So this is what I'm referring to. Okay, now let me explain more into this so that you all get a clearer picture. Okay, so friends, remember I said to you that the developer is the one that's going to build the application. So if the application the developer is building, it's a Java-based application, whether it's a standard application or an enterprise. Is somebody trying to say something? Okay. If you're not, please kindly mute yourself. All right. I'm so glad my network is operating now. I can get set. Now, once whether it's enterprise or it's a standard application, it doesn't matter. But for now, if it's a Java-based application, okay, whether Spring Boot or desktop application or web application, it doesn't, for now, just know that Java-based applications, the process that a Java developer uses is they are going to write the code. After they are done writing the code, the next thing the developers are going to do is they are going to compile it, okay, into classes. They're going to compile it, okay? And after compiling it, the next thing they will do is probably to test it. Do you understand? After testing it, they can choose to maybe they can, if they want to, there are different stages anyway. There are different things they can do to it. Sometimes they just go ahead and package it. You understand? This is what they usually do. They just do it this way. They compile, they test it, and then they package it. Okay? It may not necessarily be these steps, this flow. Different people can use, but the most important thing is that they will compile the whole codes together to form a class. Then they are going to test the code. You understand? So the build operation is a combination of all of them. You understand? So then they now package it. When they package it, okay, when they package the Java application, they are going to get something we call a WAR file, okay? They're going to generate something. So this application, when they package it into a single, all the codes will be packaged into a single file, okay? And that single file is usually called an artifact. What you call artifact, okay, is a single file. It's like a packaged file, okay? Packaged file or bundled file, okay? For Java-based application, is usually packaged as WAR files, .war. Some people call it WAR, some people call it WAR. You understand? So you're going to see WAR file, or you're going to see it named as EAR, or sometimes you're going to see it named as JAR. JAR files is popularly JAR, which this JAR means Java archive. Java archive. I don't know what this ones are, except I check online, but I know they are all, these are just archives. Okay, archives. The AR just stands for archives, but maybe the W and the E stands for different format, but the popular ones is usually JAR files. Okay, and this is usually for Java-based applications. Okay, so I want you all to have that perception, have that understanding. Okay, now .NET applications is usually going to end in .exe or MSI. You understand? Usually going because it's meant for Windows applications sometimes. Okay, Windows Microsoft environments. Okay. Now, let me not dwell on this so much. You understand? But I want you to understand that these are the processes the developers are going to take to build the application, the code. Do you understand? And the goal behind it is to get the package. Do you understand? Whether it's a Java-based application, a .NET application, or a Python application, or a JavaScript application, or PHP or C++ or C, the goal is to compile it and test it, then package it. Do you understand? Now, this process can be very, very tiring. It takes a lot of time. Okay, when we say test, they're going to write unit test. Okay, unit test cases to test every function of the code. When we say test every function of the code, what do we mean? If the code base for this CNN website that we showed you that time, right? If the code base from this CNN website, just to display this section, you see just this section here at the top, the code here, they need to test it to be sure it's working. Just this section, it needs to be tested to be sure it's working. You understand? The same way, this section, you understand? Every section of the page needs to be tested. Do you understand? Did you know that this is floating? This menu bar is floating here. As I scroll down, you see it's floating, it's hanging there and floating alongside with me. But as I scroll to the top, you see it's going to relax and expand. All those codes need to be tested to be sure they are working. You understand, right? Where do you write the unit test script? Is it inside the application? So the idea is the developers are the ones who write the unit test cases, and they usually write it inside the code because there's usually what we can have folder structures. The codes are usually organized in different, they have structures for writing the codes. You understand? I'm going to show us some demos, okay? If we don't have time, we'll cover those things tomorrow, okay? So, but the most important thing is I will try to do demo or on one or two of these applications, okay? So that we'll see how the structure is and understand it better, okay? Now, so, but the most important things, friends, I want us to understand is these processes can be very, very, why use the word monotonic now, or can be daunting rather, tiring. It takes a lot of time. So as DevOps engineers, one of our goals is to deliver softwares very fast, quality softwares very fast. Is that not true? At a very high velocity. That's what we want to do. And we employ principles of automation. We automate it. Do you understand? Good. So is there a way we can automate all these things? And that's where these build tools come in. You understand? These tools we mentioned here, this one's here, this one, this one, this one, this one. That's where they come in. They are mostly build and package manager tools. Okay? That's what they are. They help to make job easier for the developers and in turn for the DevOps engineers. Back in the days, most of these tools were not available. It was just the developers that will write the code, compile, test, and when they are done, they will just package it and now give it to the DevOps engineer or operations person to go and deploy. You understand? But with the help of beautiful amazing tools like this, job has become easier, very, very easy. Okay, so I can dwell on this, but I don't want to dwell on this. I don't want to dwell on this. Okay, but I'm sure you all understood what I've said so far. I hope this is making sense to everybody. Is it making sense? So we've covered all this. Now, the next thing, I'm supposed to do a demo. Okay. I think we've talked about packaging. We've talked about artifacts as well. We've talked about bundling, but we've not talked about this. So now, yeah, so I think we still have 30 minutes. Okay, so we still have some time.
They all mean the same thing, isn't it? The
Yes.
packaging into artifacts and bundling.
Exactly. Yes, they all mean the same thing. That was why I put the slash there. Thank you so much. All right. Friends, now, okay. There's something I need to mention, which I will come here because I need to talk about the, what is it called? I need to talk about the reason why we call this, I had a reason for writing it this way because I wanted to talk about, I think the 10th one, okay, let me just put it as the 10th one here, and that is dependencies. Dependencies. Yeah, am I correct? Dependencies. Okay, good. Yeah, dependencies. Now, what does that mean? Okay, I think I'll talk about that, then I'll start my demo. Okay, so now what does that mean? Friends, sometimes when developers write their code, right, their JavaScript codes or Java code or Python code, whichever one they write, sometimes they intend that their application it's going to be smart enough to do a lot of things. Okay, so they will write their codes inside here. Okay, they will do a lot of things inside here, writing their codes here. Okay, now sometimes they want their code, their application, to be able to talk to a whole lot of things, right? Maybe, just maybe, it could be a database. Maybe there's a database here. I want my application to talk to a database, right? Maybe I want my application to also talk to another service somewhere, or connect to something like an API, connect to something elsewhere. Okay, now this code on its own, or let's say in this application, I also want my code here to connect to somebody else's application that displays weather. Okay, maybe this person here has written a code that can help you to know the weather of the day, right? And this is the database, and this is maybe another special service. And I want all these services, or services in this case, to be connected to my application. And you can access all those things from my application. Friends, do you agree with me that when you open your mobile applications, especially for your bank applications, right? Behind the scene, a lot of things happen. For some of you that try to pay for airtime services, airtime, right? You try to pay for airtime. Do you know that behind the scene, your bank is communicating with your internet service provider? That's the telecommunication company that is going to be providing you airtime, right? Good. So behind the scene is connecting to a lot of services. Okay, you can pay a lot of other bills, and behind the scene, your application is connected to so many things. I did not get what you said about banking. Okay, what I'm saying is sometimes you can have an application that talks to other services. Okay, some mobile banking apps are designed in a way such that they can be used to pay. They can be used to pay for what is it called? They can be used to pay for TV shows, right? Maybe your Netflix, you can pay it from your banking app. You can use it to pay for your groceries, maybe a mobile, just all inside the same app. And at the same time, you can also use it to check for weather, something like that. What I'm just saying is an application code can be designed to communicate with different other services. Okay. Now, one of the things the developers do is, because this code here depend on this, and this to work, right? It depends on each one of them to work. So there's something we call dependency. Dependency. Okay? It depends on it. So this service, right? They usually have some tools. For instance, if this is a Java-based application, right? So this database, right, has a jar file. Okay, I wish I can write this. Okay, I'm not using my pen tool. Okay, but the most important thing is they have a jar kind of dependency, right, that you need to download. Okay, once you download that set of codes, your application will be able to talk to their service. Okay, you will get that tool, the jar application, from them. Okay, now you are not aware of it, but this happens behind the scene. The same thing, it needs to download, get the necessary jar file. The same thing with this, it needs to get the necessary jar file. Okay, it gets it from here and it pulls it. So you're going to see a lot of lines of codes here. Okay, but whenever it runs, it is pulling the code from different application or different code base, or what we call repository managers. Now, this will make sense when we start doing some of them in real time. Okay, but I just want you to know that sometimes the code of the developers depends on external resources. I'm saying this because sometimes in terms of security perspective, if the developer does not, especially if you are somebody that wants to start tilting towards DevSecOps, right? Code injections and the rest of them, you want to be sure, you want to make sure that all the dependencies are not they are properly updated and there's no vulnerability in them. You understand, that can be exploited. You understand? But don't worry, we'll still talk about some of those things. But I'm sure you all get the picture of what I'm trying to say. Okay? So it's very, very important. Some of these build tools can also act as dependency manager tools. That's what I'm saying. That's the reason why I'm explaining this. For example, NPM can also serve as a dependency manager tool. If you go to NPM repository, if I'm correct, I think it's NPM repository. Let's check it. NPM repository. Yes. Yeah, npmjs.com. Yeah. So this is where you're going to see all the packages. You understand? Different packages, different people has uploaded here. So if as a DevOps engineer, I'm writing a JavaScript application and I need something that can do certain things, this is where the developers usually pick it from. Now, this is too much information. The same thing for Maven. We also have something we call the Maven repository. Okay, we have something we call the Maven repository. Okay, so I just want you to know there's something called dependency. Okay, so let's do some demo right now. Let's do some demo. Okay, so which one are we going to do? Okay, I'll start from the simple and then I'll move to complex ones. Is there anybody on this call right now that has what is it called? That has been able to create an AWS account? Anybody? Anybody? Yes, okay. Let me see if this, okay, good. Okay, for those of you that do not have what is it called, that has not been able to create your AWS account, please use your Vagrant to spin up an Ubuntu instance. Okay, use your Vagrant to spin up an Ubuntu instance. Okay, please, let's do that. So let's see. Let's see if this is going to open very fast. Okay, so but if it's taking much time, I can log back in. Let's see. Okay, it's going to take me time to get the credentials. Let me see if I can use my killer .sh playground. Okay, so oh, so sorry, I didn't remember to get the credentials for this. It's in my phone. I have to start searching for it and get the login. But I'll use this. I'll use this platform. Okay, I'll use this environment. It's just the same. It's just to get an environment. I can use my Windows computer too, but I want to use something we're going to be using in the real world. Okay. Now, friends, this is an operating system, an Ubuntu machine, right? Now let's start from the simplest, from the simplest. Okay, from the very, very simplest. Okay. And one of the very simplest could be a Python code. We'll do something very simple, Python, and then we'll now do something on maybe Node.js, on a JavaScript application. Okay. Then tomorrow we'll now do the big boys. Okay. We could just do something on Maven tomorrow. Okay. And then of course, when we start talking about web servers, we'll now do things like Apache, Tomcat, Apache, HTTPD, and then we'll now talk about Nginx. All right. So in case you're wondering if we're going to touch it, the answer is yes. So I really want you all to be grounded to understand this rudiments. Okay, so we have 20 minutes left. So if you are given, usually what happens is this. You remember I told you that you'll be given access to the code base. Do you all remember? Where I told you that as a DevOps engineer, you'll be given access to the code base. That's where the code is being stored, right? So normally, what you're supposed to do is, the way it works is, you're supposed to go and set up a server somewhere. Okay, you set up a server. And by a server, we mean just get a computer system, okay? And then configure that system with the right software, okay? If it's a web server or an application server, just configure the right server. If it's a CI server, install Jenkins, okay? Or GitLab runner on it. But if it's a web server, install Nginx or Apache. That's what I'm trying to say, okay? Just install the right software that will make it a server, okay? Now, in this case, this is a computer system, okay? So, if the code will usually be stored in a folder like this, okay? A simple folder like a GitHub repository like this, okay? I think I found this online. So I think I may use this, or I could use this one too. Let me see, I could use this one. So, but let's see if we can still do other things. So if I want to write a simple Python code, right? A simple Python code, I can just come here and just type, okay, let's create a folder first of all, mkdir to create a folder and call it Python /app and hit enter, right? But let's create the other one. I'll call it Node.app. Okay. So if I type ls, you see these are the two folders I created here. Other ones came with it. Came with that the OS, with this environment rather. So I'm going to cd or move into this Python app. Okay. So cd into Python app. Are we together? Now, it could be a very simple command. Let me do the funniest thing. But one of the funniest way of creating a Python application is you can just create an application. Let's say the file I want to create, I'll just say touch, okay? And then let's say the file is usually app.py. It is app.py, okay? Friends, take note of the steps, okay? Take note of the steps. The first thing I did was to create a folder. The second thing I did is to move into the folder. The third thing I did is to create my file, okay? So if I type ls, you can see the app.py. Now I'm going to add contents into that file, okay? So I'm going to use nano or vi. Okay, let's use nano and open the app.py file, okay? I wanted to use Flask, but let's keep it very simple. Let's just use something dummy. Let's say hello. It works. And close it and do this. So this is a simple Python line first code. To get this to work when I started back then used to be very difficult, but it seems so easy now. So this is a simple Ctrl X, Y, and save. You understand? So if you use the cat command to check that file, you see there's something inside. Is it true? So this is me trying to tell you that let's assume that this is the code the DevOps engineer gave you. You don't know what is inside the code. You don't know the contents of their code. The most important thing is that they gave you the code. How do you test that the code is working? Right? That's the first thing. That's the first thing. You need to confirm that the code is working. Right? Now, if it's a Python application, the simplest of it, the first thing you need to consider, ask yourself, is Python installed on this machine? Right? You need to install okay, there's a way it works. There need to be a suitable environment, okay, more like an interpreter, something that's going to interpret your code, okay, and convert it from your normal code, which is your ASCII format, to byte code, which is more like machine code that the computer can understand. But what I'm saying is we need to run this code, right? And whenever this code is run successfully, what we are supposed to see is hello, it works. It's not supposed to display all these things, okay? Now, how do I make sure it works? The first thing I'm supposed to do is to install Python. Do you get it? The first thing you're supposed to do is to install Python, set up the environment. So let's check if there's Python on this computer. Python-v. Okay, so there's actually Python on this computer. It's already pre-installed. Exit. Yes, sorry. Clear. Let me see. Python, is it? Let me see. Dash version. Am I correct? Let me see. Yeah.
No.
So
okay. Because most times it's meant to be Python 3 then dash version.
yeah, okay. The latest one is actually Python 3. I think they've actually cut down support for version 2.
Yeah. So no. So what I'm saying, most time when you want to run the command, I don't know, maybe it works for Python, but most times it's usually Python 3 then space dash version.
Okay. Okay. Let me say something to that effect. What usually happens is this: if that operating system also have maybe Python 2 in it, right? If you put something like Python 3 like this is what Mr. Mayowa is saying, right? If you do it like this, you see it still worked, right? So because this is assuming that the version of Python you're using is Python 3. Okay, so if you also have something like a version 2 of it, let's see if it's going to work. Okay, so Python 2 not found. You understand? You see, it's telling us I can install it. So because there used to be a version 2 of Python. You understand? So the reason why some people usually put this 3 here is because if you just put only Python, it will be reading Python 2 and they will be getting Python version 2 here. But if you want to get the version 3, you put Python 3 in front of here. Okay, but I think this one was configured correctly, and that's why when you put Python space version, you can get this. Okay, so right, so let's continue. So now for those of you that may not have it on your computer, I am sure, hopefully, just this alone, apt install Python. Either you do it like this, or you put the 3 in front of it. Or if you press tab, let me see. Let me remove this. It doesn't work. So I was thinking autocomplete is going to work for me. So if you do it like this, sudo apt install Python, you should be able to. Or as a DevOps engineer, you may not know how to. Just come here and say how to install Python on Ubuntu 22.04, maybe the latest version. You see, there'll be an article. You see, that's the reason why I'm telling you all to write your articles, because who knows, your article could be solving somebody's problem. You understand? So this people has written article. You click here, and you see this was just written last year, December. And when you follow these instructions to read, you see this is Python 3. This is, you can read more, this sudo apt update. So this is it. This is what I was saying. So once you run this command, it's going to install Python for you. I hope this makes sense. This is exactly what we are doing. Okay. All right. So I think we're good to go. Nothing. I don't need anything here. Okay. Good. So please, if you're following me, that's the reason why I'm explaining that. Okay. So if I want to now Python has been confirmed to be available on this computer. Can we now run that application? The answer is yes. How do we run it? If I do type Python space and put the name of the file, app.py, and hit enter. Did you notice it works? It's telling us, hello, it works. So normally, now this is the simplest aspect of it. Okay, for a Python application, especially for real world use case, you usually use things like web frameworks like Django, or you're using Flask or other ones. Okay, but it's usually Django or Flask. If possible, we might touch. I used to have some snippets somewhere around, but maybe because of time, I don't want to start writing it and then start explaining it because of time. Okay, but this is a simple demo, a very simple demo. Okay, they give you the code and you confirm that it's working. Okay, so now because this is not configured in a kind of local server environment whereby it can be listening to a port, that's why I will not be able to use we can do this in a way such that you can use your IP to test it or use the browser to test it. Okay, so but if you understood this so far, please type yes on the comment section. I want to be sure you understood this. At least this the simplest. Okay, beautiful. Thank you. Okay, so this is the simplest Python application we've just tested. Okay. All right. Thank you so much, everybody. Now let's move to the next one. Okay. If we have more time tomorrow, I'll talk about. We might give another example of maybe a Flask application. Okay. So now let's talk about a Node.js application. This time around, I'll do two of them. The simplest one, and then we'll now do a real world one. So it can be either this one or we'll use this one here. Okay. So, but let me just give you a perspective on how it works for the Node application, Node.js application. That's a JavaScript application. Whenever we say Node, we're referring basically to a JavaScript kind of application. Now, if you type pwd and hit enter, it's telling us I'm still in the Python application, right? cd space ... Friends, if you're seeing /root, don't get confused. It's because of this environment. It might not be the same on your own computer, okay? You might be seeing Ubuntu on your own or the username of your computer, okay? Don't bother about that, okay? Just know that you were in the folder and you just stepped out of it. If you type pwd, it will tell you are out of that Python application. If you type ls, you can see Python and you can see Node app. Are we together? All right. Now, let's move into the Node application. All right. So we're into the Node application now. Okay. So inside this Node application, this I'm going to use a boilerplate or something we call a template. Okay. If you're conversant with creating Microsoft Word documents, friends, do you remember that whenever you create a Microsoft Word document, when you want to create the Word document, if you open the application for the first time, it will tell you do you want to choose any of these templates to create your Word document, like so that you can follow their style and pattern to create something. So it's the same thing. So whenever you are creating something, a Node.js application, so what I want to do now is actually a back-end application, back-end. But even though it's going to be displayed on the front end, that's on the browser. But let's just take it slow and steady first. The Node application, I'm inside the Node.js environment, right? And there's nothing inside. Okay, so I'm going to create a simple file. Okay, and I'm going to use touch to create that file. I'm going to call it app. It can be any name, app.js. Does that make sense? Now, if I hit enter and type ls, I can see the file. Now, let's use vi instead of nano now. Vi space app.js. If I hit enter, I've opened the vi editor. I'm sure those of you who joined the class on Linux will understand this. This is simple for everybody. Now, if I press I'm in the insert mode. Is that true? The insert mode. Good. Now, in this insert mode, I can type. So what I want to do, I can type something here, but let me just go and get some templates. So I'll just come here and say Node Express, or yes, let me just say, okay, Express. Get started with Node Express in minutes. Okay, let's just get this. Let's see. Let's see. I don't want to use your code pilots. Thank you. Sorry, don't do it for me. Thank you. Just give me the search results. or let me see. Any of this code will still do the job for me. I'm going to share it for you all. So let's see. Okay, let me share this Python to install it. So I feel this might be helpful to anybody installing Python in Ubuntu. In case you need the link, here is the link. All right. So I'm going to this now. Now this is to quick start. Okay. All right, good. So beautiful. This is good. This is good. Very, very simple. Very, very simple. Very, very simple. Okay, so I'm going to copy this and share it to you all in case you want to reference this later. All right, so I want to create a Node application, okay? A Node.js application. So it's telling me the first thing you need to do, okay? You need to ensure that Node is installed on your computer, okay? That's the first thing. You need to ensure that Node is installed on what? Your computer. Node is installed on your computer. All right. When you confirm that Node is installed, and not just Node, you also need to confirm there's something called NPM, okay? Because when you install the latest version of Node, of course, it's also supposed to install NPM. Now, you may be wondering, what's NPM? I said that before. That's the build tool or the package manager, okay? That will help you to manage your dependencies and the rest, to package your code and the rest of them. Do you remember our notes? For our notes. So for now, because we didn't do any big application, that's why I didn't talk about this. Okay. So but this JavaScript application, we want to do something, and that's why we need this NPM. Okay. All right. So let's install Node. So we can either go to their official website. If you're using AWS, right? Please, I want you. This is how you're going to get it. Just type AWS EC2 Node, how to deploy Node.js in AWS EC2. Yeah, this is good. There's usually a particular link. I will share it to you all once I see it. Let me see if it's this. Once I see it, I'll know. I usually use it because that's the commands that works on literally all the servers I've worked on. So just hold on for a few minutes. This is taking time. Okay, we can even copy this code. This is, in fact, this is a dummy code. They've already prepared a dummy code for me. You understand? So, but I'm trying to. Let's see if this does not give me as fast as whatever. So, two ways. If you were using a Windows computer, you can click here to download Node.js. Okay, it will install the MSI version for you on your Windows computer. But I'm sure if you need it on, if you click on download, you can. If you click on this, you can choose different architectures you're working with. You understand? Now, if I say Linux, this is how we're going to do it. So this is going to help us. Okay, hopefully this should do the job for us. Yeah, this is wasting my time. Okay, I've stopped it, but this is actually what I needed. You see this thing here? This is what I needed actually. So it's the same thing here. Can you see? I'm sure you all know how I got to this place. So I opened the Node.js application website. Once you just type Node.js, okay, on your Google, just type Node.js here. Node.js, okay, and it's going to take you to their website. Either you click on Node.js download or you just click on the download page here. And once you do that, it's going to ask you what you want to do. Normally, I want, because I'm installing it on, I want the package manager, or you can just choose this and say, see, Linux is disabled here. So, but because it's under pre-built, just click on package manager, click here and select Linux. And you're going to see all this. Just click on this to copy the code. It's going to copy everything. then we can just come here and okay. So let's close this file first. Sorry. Escape and say column Q. We didn't add anything inside that file. Take note. ls, nothing. So we want, the first thing we are supposed to do is to install Node. Is it not true? So I'm going to right click and paste that command. So right, so let's see. Node not found. Let's see. NVM not found. Okay, let's see. Okay, so now we've done that. Let's say apt install Node.js -y. Okay, so if I hit enter, okay, so of course the next thing you're supposed to do is to install npm 2. But let's just confirm. Now we are done installing Node. If I type node space -- version, sorry, version. Okay, this is version 19. Actually wanted the latest version. So that script did not work the way I wanted. Okay, npm is not installed, so I have to install this apt install npm-y. Another thing you can do is to update your repository first of all before you install. I was supposed to do sudo apt update. Maybe that's why I didn't get the latest version of the node. But either way, let's see. Hopefully it's supposed to work. Okay, because this file I was trying to open, this is supposed to give us the latest version. v039.7. Let me see. This is the same thing. So install 20. So nvm. So I'm surprised why this is not working. I'm surprised. So but let's just, so npm, so let's confirm if npm is installed. Okay, so npm is installed now. Are we together? So two things we did: we installed Node.js and we installed what? npm. Any confusion? I'll press Ctrl L or I'll type clear. Ctrl L or clear, and it will wipe the screen. Okay. All right. If I type ls, you notice that nothing, as though nothing happened, but I've installed what I need to install. Okay. So now that we've confirmed that Node.js is installed, the next thing we are supposed to do, we are supposed to create a new Node.js project. Okay. This is how to create. This is the way developers do it. So that's why I'm walking you through this step. Create a new Node.js project. So the first thing you're supposed to do is to run this npm init-y. It will help you to create the package.json file. I know you may be wondering what I'm saying, but don't worry, it will make sense over time. Okay, so I'll copy this package npm init-y. So I'll come here and I'll paste this. Okay, so I'll hit enter. So now normally you see it filled in this information for me. What if I had done npm space init, it will be prompting me and I'll be filling those responses. It will ask me what's the name of your project, what version do you want to create, what description, what's the main file. It asks me all this information. But this -y means don't send me any prompts, just give me the default. Okay, so that's why we have something like this. So if we type ls now, we're going to see two files there. The original app.js we have, and then the package.json we have. Okay, so this will help us to store all this. This file is where we can store all our dependencies. Okay, if you are, I'm doing this so that in case your developer build this code and give it to you, you can make sense out of it. That's the reason why we are doing this. Okay, so the next thing we need to do, let's read as fast as possible. If we click npm install express, is going to install something we call Express.js. Okay, the application we are trying to install. Okay, let's quickly do that. Okay, let's paste it and hit enter. So good. This is, so if I type ls, you're going to see we have some modules now. We have more things here. And if you check the package.json now, sorry, package package.json, did you notice that we have dependencies here? I just added one dependency, which is called Express. Did you see? Dependency. Okay, so this NPM install. So with the help of NPM, Node Package Manager, I was able to install a dependency. Okay, so now what that Express is going to help the developer to create this application faster. That's exactly what it just did anyway, in a nutshell. So this is the application code. Just copy this. All right. I would have explained each line for you, but again, let's just open our app file, vi app.js, and then insert mode, press I, and then paste this command. Are we together? So I'll just leave it the way it is. Okay. So, but this is the proper format. This is the way it's displayed. Constant this is getting the express, this is invoking it, and then putting the endpoints and the rest of them. So, but don't worry, and this is the port it's going to listen on. This is just what we have here. Okay, a simple application. Don't worry about what it's doing. Assumably, you are not the developer that built this, but you just got a sample code, right? And that is exactly what we have here. So let's close this. Press escape, or see what I want to do. Let's come here, and instead of hello express, let's say insert. I press I again and say hello Chief Mayor. Okay, and press escape, column WQ exclamation, and hit enter. Are we together? I hope I'm not too fast. Good. So now if you type ls, this is what we have. Now, I think we are ready to go. And if you come here, we are ready to run our Express application. How do we run it? We'll type node space app.js, node space app.js. So if we come here and type node, which is the local server, and say app, the name of the file, and hit enter. Can you see? It's telling us our server is running on port 3000. And I can confirm this because I'm working on this environment. In your own case, what you will do if you get to this point, just open the browser and just type localhost. Okay, just type localhost column 3000. Okay, this is what you're supposed to do, and it will work for you. But in my own case, it's not going to work because this environment, this is inside a Linux environment. This is different, okay, from my computer. So the only way I can get this to work is if I click here and say traffic ports, this port here, this section here, and then it's going to open this section. And then did you see what we have here? So this, I can use port 80, port 8080, but in this case we're using port 3000. So I'll just come here and put the port that I want, 3000, and I'll click on access. Can you see? Our code is working. Hello, Chief Mayor. Can you see? So this is working. Any question? Any question? So if I copy this link, let's test it from your end. You have lots of questions. Yeah, we're going to wrap here so that I can take questions, and then let's test this. Can somebody click on it? Can somebody click on this and confirm? Okay. Confirm if you can see hello Chief Mayowa from your end. Okay, that's fine. That's fine. It's working from your end, right? Beautiful. So that's just it. So assuming your job as a developer is just to package it, is just to build it and deploy. It's just to deploy it. That's all. So the code was given to me. All I did was I did the whole necessary magic and deploy. It's working fine. So I'll just give the customer or give my boss this IP and tell him, so go and test it. It's working fine. Okay. So, so you all should go and try this, right? This will be our exercise for today, right? So this is a simple application here. You don't need to bother yourself. Do we use this, or let's use this? Okay, let's use this one because this is using Yarn instead of NPM. So let's try it. So if you try it, if you're able to test it, please take a screenshot and share it on the channel. If you're not able to, we'll do this tomorrow. Okay? So I don't stay longer than this so that I don't mix the video too lengthy. Okay? So this is the link. Okay, please, this is an exercise. Let's try it. Okay? So try to pull this image. I'm not going to walk you through how you're going to do it. Let me see how you're going to go about it. But let me give you a hint. Because this is available on GitHub, it means that on the server, you have to install Git. And then use Git to clone it down to your computer. You see? Then you have the folders there. And then it's the same thing. Then remember, you need to be reading something we call README. So you can use the README file to read. And then, but the problem with this README is that there's no, they didn't give the approach on how to deploy this. And that is where the problem is with some companies, okay? There needs to be proper documentation as a DevOps engineer, okay? Your README is supposed to contain steps on how to deploy this application. Any questions so far? I think we've exhausted, covered a lot. Yes, I can. Sure, sure I can.
Can you go over, is this the assignment?
Yes, the exercise is just for us to deploy this and then send me a screenshot either from your local computer or just if you want to use if you want to use this kind of platform to do it, fine, so that you can get a public IP like this, or if you want to spin up an EC2 instance and do it and send me the public IP to test it, fine, whichever one works for you. But I just want you to deploy this code here, this set of codes here.
Okay, deploy code. I think my question was about spinning up an EC2 instance, but I think I should maybe give it a try first and ask you, because I was going to ask, say I spin up an Ubuntu server on EC2, blah, 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 and I'm creating a file. I create a file like an app.js. Is that file residing on my server, my Ubuntu instance, or on my laptop?
It's on the server.
Okay,
it's on the
server
and not on your local computer. Yeah.
Right, that makes sense. Okay, I think okay. So we should use an Ubuntu instance, right, to do this, right? Is that your question? Is that the assignment?
Either of them. The most important thing is I just need an IP to be able to test that the code is working.
Right.
You understand?
Okay.
I want to see something that looks like this, a home page that looks like this. Yeah, this is the result.
All right.
Okay, thank you so much. Any question from anybody, friends? Or are we tired? Did I confuse you all? Did we do too much? Trying to maximize this, so, but for some reason I can't say. Any question? Any question? Mr. Pope, Mr. Habib, Mr. Kanu, Mr. Benga, Bowie, are we together? Can you all still hear me? Any question?
Yeah, we can hear you. So actually, it looks easy, but I think I have to rewatch the video because I got lost in between. I don't know why, but
Wow.
what you did just looks very easy. I got lost, so I have to watch the video.
Okay.
Again.
Okay.
Definitely.
Okay.
Yeah.
Okay. That'll be important. Just watch the video and then give the task an attempt and see what happens. Okay. But so far, from everything else we discussed, I hope we learned something and it made sense. Over time, it's all going to make sense. We'll be able to connect the whole dots together. Okay. All right. So if there's no question for me from any other person, then I'm going to stop sharing my screen. I would love to thank every one of you for listening. Thank you for joining us on today's session. And do have a great night's rest. Good night. I'll stop sharing. I'll stop the call
Yeah.
now.
Right, sir.
All right. Good night, everybody. Okay, Mr. Habib, you have a question? Okay, your hand is raised. Go ahead, please. Okay. Guess that's a mistake. All right. Good night, friends.